Hi, Assalamualaikum. My name is Nuzalika. Today, I will introduce Autodesk Civil 3D. Civil 3D is a software made by Autodesk. It is used by a civil engineering project like road, highway, land development, and drainage system. With Civil 3D, we can create a Civil 3D model such as surface, alignment, profiles, and corridors. One important feature of Civil 3D is object-based design. This means when we change one design, the other related design updated automatically. It is more flexible than 2D drawing and help reduce mistake. Civil 3D also help us visualize the terrain and design clearly and calculate earthwork volumes. The benefits of Civil 3D are many. It improves work efficiency, support teamwork, and work well with other Autodesk software. It also helps engineers to make a better decision, especially for complex project sites. In short, Civil 3D make civil engineering design faster, clearer, and more accurate. Today, I would like to talk about our project location, Kampung Seronok in Pulau Pinang, Malaysia. This is a rural village that mixes residential home with a farmland. The roads are the main way for people to travel and move goods every day. However, there are some big challenges. These current roads are too narrow and the drainage system are too poor. This causes a safety issue, especially dangerous water ponding when it rains heavily. The solution is Civil 3D. So why we need Civil 3D? First, it help us analyze the land and road layout very accurately. Second, it allow us to design better road path and proper drainage to stop flooding. And finally, it let us build 3D model to ensure a new design is safe and efficient for a growing population. In short, let's move to our objective, the left side. Moving to our objective, our main goal is to create a full 3D model of the road in Kampung Seronok using Civil 3D software. This allow us to analyze the land accurately, calculate the material needed for construction, and design a road system that is safe and well drained. Okay. However, right now, we face several transportation issues. The current roads are too small for traffic and damaged with potholes and cracks. Worst of all, because of the poor drainage, water collects on the road when it rains. This combined with a lack of proper road sign and light create a high risk accident. The solution is to solve this. We propose three main solution. First, we will upgrade the road surface to be stronger and smoother. Second, we will use Civil 3D to design a better drain to slope to stop water flooding. And finally, we will widen the road and add a proper safety sign to protect the driver. By doing this, we ensure the road in Kampung Seronok are sustainable and safer for the future.
Hi, my name is Ahmad Naim Solehin bin Kamal, and right now I will be presenting the subtopic of modeling. So the first part of modeling is existing ground conditions. Before designing a 3D terrain model for Kampung Seronok Pulau Pinang, it is essential to gather and understand ground conditions to ensure the model accurately represents the area's real-world terrain and is suitable for any civil engineering or planning projects. The second part of modeling is surface analysis. Kampung Seronok require less extensive effort of excavation compared with steep or mountainous areas, making it suitable for detailed modeling of existing terrain and precise road alignment planning. Civil 3D can accurately represent these subtle local elevation changes to support corridor design, cut fill analysis, and grading strategies. For the next part is alignment and super elevation. Alignment is defined road or center line of a roadway that governs its geometry in both the horizontal and vertical planes. It acts as the fundamental framework upon which the entire road design is developed. Super elevation is the intentional banking of the roadway or horizontal curves achieved by raising the outer edge of the road relative to the inner edge. This design feature helps to balance the centrifugal force acting on the vehicles as they travel through curves, improving safety and driving comfort. On this slide, I'm going to explain about four things. The first one is longitudinal section. The longitudinal section illustrates the vertical profile of the road alignment along the proposed road, showing how the elevation changes along the path. It provides a detailed view of the road vertical geometry, including gradients, slopes, and changes in elevation, which is essential for accurate design and construction planning. The next one is assembly and corridor. Road assembly was designed in Civil 3D using common element of road design. Then with shoulder and side slopes, this assembly was subsequently applied along the design alignment to obtain a continuous corridor model, which depicts the final 3D road geometry of the project area. The third one is cut and fill calculations. Cut and fill calculations were performed in Civil 3D using the corridor model to estimate the required earthwork volumes, and this analysis identifies the area of excavation and embankment, supporting efficient construction planning and cost estimation. The last one is cross-section detailing. The cross-section detailing will produce at a selected chain edge along the alignment to show road width, side slopes, and ground levels to provide essential information for construction accuracy and illustrating how the road fits within the existing terrain.
For my part, I will present the analysis and discussion of our Civil 3D highway design project at Kampung Seronok. First, for the analysis of existing ground conditions, the topographic data was imported into AutoCAD Civil 3D to generate an existing ground surface. The study area is mainly rural, characterized by gently undulating terrain with several low-lying areas near residential and agricultural zones. Along the proposed road alignment, noticeable elevation differences were identified. This variation may lead to cut and fill challenges during construction, making it important to understand the existing ground condition in order to minimize excessive earthworks and environmental impact. Next, the surface analysis and terrain implication were carried out using Civil 3D tools such as contour and slope analysis. The result shows the presence of moderately steep slopes and terrain depressions. Steep slopes may increase the risk of erosion, while low-lying areas are prone to water ponding during heavy rainfall. These findings emphasize the need for effective drainage system and suitable slope protection measures to ensure long-term road performance and safety. Moving on to the alignment and super elevation design issues, the horizontal alignment was designed based on terrain conditions and existing and constraints. Limited right of way and nearby developments, restricted curve ready in certain sections. Super elevation was applied at curved segment to improve vehicle stability, especially during wet conditions. However, it was carefully controlled to remain suitable for low-speed rural roads and to comply with relevant design standards. For the longitudinal section analysis, the vertical profile was examined to control road gradients and elevation changes. Excessively steep gradients were avoided to reduce braking demand and improve vehicle performance. Where elevation changes were unavoidable, smooth vertical curves were introduced to enhance ride comfort, visibility, and overall driving safety. Civil 3D allowed real-time profile adjustments, helped to optimize the design and reduce unnecessary cut and fill work. In terms of road safety and performance, proper integration of terrain, drainage alignment, and profile design is essential. Issues such as water ponding, narrow road section, and inadequate curvature can significantly increase accident risk, particularly during adverse weather conditions. Through systematic analysis and design optimization, the proposed road improvements aim to enhance vehicle stability, reduce hydroplaning risk, improve traffic flow, and extend pavement service life. Finally, the role of AutoCAD Civil 3D was crucial in resolving the design challenges. Its object-based modeling enables automatic updates between surfaces, alignments, and profiles, reducing errors and saving time. Advanced visualization and analysis tools also help identify potentially issues early and ensure compliance with engineering standards. Overall, Civil 3D significantly improved design, accuracy, efficiency, and safety for this rural highway project.
Assalamualaikum warahmatullahi wabarakatuh, and my name is Ahmad Muaz bin Hambal. I'm entry number A201143. Moving into a technical design detail, our 821 meter road corridor focus on two things: standardization and safety. By maintaining a consistent assembly, we have ensured a smooth surface that simplifies the construction process. For geometry and safety, to handle tighter curve, specifically our 135 and 175 meter ready, we have model precise super elevation transition. This ensures vehicle safety against centrifugal force while maintaining a level 0% grade where needed for drainage control. Next is about the earthwork challenge. The most critical takeaway from our analysis is the site vertically. We have a 46-meter elevation spread. Because our proposed road level are currently set low, we are trending toward a cut-heavy operation. However, there is a good news. Over 107,000 square meter of a site is a class 1 slope, meaning it's flat enough to standard machinery and easy development. The class 4 zone, the slope over 75% only represent about 4,700 square meter, but they are our primary cost driver. To optimize the budget, I recommend we slightly raise the road term and lower area to balance our cut and fill volume. So, for data accuracy and drainage, we have back this finding with high resolution data. By using 25 meter chainage interval in our 3D model, our volume estimate are highly accurate, leaving little room for error during construction. Finally, we must consider drainage because the site peak at 47 meter, a low road profile could act as a dam. Our next step involves a strategic culvert plan to ensure runoff moves safely from the high points under the corridor and away from the developable land. Thank you.
Hi and salam sejahtera. Today I will briefly present my project on design improvement using Autodesk Civil 3D for a road at Kampung Seronok, Pinang. This project focuses on a rural and hilly area where road design is more challenging due to uneven terrain, nearby houses and agriculture land. The initial road design had several weaknesses because it was not properly aligned with the natural topography. As a result, there were issues such as excessive cut and fill, steep slope, limited site distance, and poor drainage which could increase construction costs and safety risks. To address this problem, Autodesk Civil 3D was used as a main design tool. First, a 3D digital train model was developed to accurately represent the existing ground condition. This allowed a better understanding of the actual site compared to traditional 2D drawing. Next, the horizontal alignment was optimized to follow the natural curvature of the land, reducing sharp bend and improve vehicle maneuverability. The vertical alignment was also improved by smoothing the step gradients and making the road safer and more comfortable, especially for heavy vehicles. In curved section, super elevation was applied to enhance vehicle stability, particularly during wet weather condition. In addition, drainage analysis was carried out to identify runoff paths and low points along the road. This helped in proposing suitable side drains and cross drainage location to prevent water ponding and pavement damage. Civil 3D was also used to calculate cut and fill volume dynamically, allowing better cost estimation and construction planning. Overall, the use of Civil 3D result in reducing earthwork, lower construction costs, improved road safety, better drainage performance, and also higher the design accuracy. This also supports more sustainable and environmentally responsible road development. In conclusion, overall findings of the Civil 3D highway design project at Kampung Seronok, Pinang is very useful for road design in hilly rural areas. So, using train modeling, optimize the alignment, corridor design, and outward analysis give a more accurate view of the site than the traditional 2D methods. The study also shows that a Civil 3D helps identify and fix the problem, such as too much earthwork, step slope, and poor drainage early in the design stage. So we can identify the effectiveness of civil 3D in highway design for a Penang or current road, and also we are recommend the future highway project using 3D design. Thank you.